Hello everyone, welcome to my channel. So today we are going to do blind 75, one of the question, kth smallest element in the binary search tree. So the binary search tree where everything is in sorted manner means the left node which is there, that is less than the root, and root is less than the right node. So that is one of the biggest advantage, and in that if we are required to figure out any smallest element or any largest element, all those could be easily figured out just by doing any sort of traversal which is there, like in order or pre-order or post order. So that's the thing. But see, when we do a in order traversal, there the thing would be left, right, left, root, and right. When we do a pre-order, there the thing would be root would be traverse first, and then left and right. So when we do a in order traversal, at that point of time we are able to traverse the binary search tree in ascending order, and that gives us edge of figuring out the largest or smallest element. So like that only, as per the heading of this question, here we will be just straightforward going ahead and doing in order in order traversal and figuring out that where the kth smallest element is and just returning that element. That's straightforward we can do. This is a binary search tree. Her time complexity, space complexity anyhow would be determined by traversal, which we will be doing. At max it will go ahead with order of n. We won't be doing any sorting as already everything is sorted. So n log n, again it won't be the case for the time complexity. For going ahead with like n square solution, anyhow we won't be able to reach that much far that we'll go ahead with some n square solution. But here the time complexity would be in order of n only, and the space complexity we won't be using any extra space, only the stack space would be used, means the stack internal stack which is there, that would be used, and for that only order of n space would be there, and that also in the worst case scenario. But I'm like not sure in binary search tree if there is a skew tree or not. Now whatever constraint would be, those would be that manner only in this question also. The way it could be done in order of n, and possible solution would be only one possible solution, that is doing in order traversal for this, so that we can get everything in ascending order. So now let us straightforward go ahead with the coding part for the same. So yeah, like I haven't read this question, but I hope you have already read when I was speaking everything. So now let us straightforward do coding. We'll just go ahead and do the in order traversal, and that is we will be able to figure out that how we need to find the kth smallest element. And kth smallest element refers to that first smallest element, then second smallest element, then kth smallest element. Means first smallest element would be 1, then second smallest element is 2, and here k is equal to 1, so this is the kth smallest element. If k was 4, then this 4 was the kth smallest element. So now let us code it. So the first case would be in order traversal. Also we would be writing, I will be doing this in order traversal in recursive manner. So our base case would be when root is equals to null. So at that point we'll return -1. That simply refers to that we have either reached the null point of the leaf node, or we don't have any node there, so that's why we will be returning -1 to its parent column. If root equals to null, then we will be returning -1. Now the next part is doing the ascending order traversal, that in the case of binary search tree basically we are going ahead with the in order traversal. So for in order traversal we would be having first the leaf left node, left subtree traversal would be there. So for that purpose we will be going ahead with kth smallest, okay, kth smallest function we will be calling that, and going ahead with the left subtree and passing k into the same. And then we'll check at this point only, first we'll check that if k equals to 0 or not. If that is the case, then we will return our left which is there. If that is not the case, then anyhow we'll just decrement our k, and then we'll check again that if our k equals to 0, then we'll check, okay, if it is equals to 0, then we'll return whatever at that point value of root is, that will return. And because it is a in order traversal, so first the way we did for the left, now we need to do for the right also. But rather than keeping a separate variable for right, we can directly go ahead and return the right side of the same by just doing this kth smallest and then root and then the right side of the tree and the k. So this was all for this, and then we can just run this code and check if there are any compilation issue. Okay, basically there is wrong answer. Let us check that where exactly it was throwing the wrong answer. So if we check, root is fine, left equals to roots left, we need to check. Then if k equals to 0, then we'll return the left side. Then we'll do the k minus minus, because anyhow we need to subtract that and reach at that particular point. And yeah, okay, here the main issue which was there, because see, that is basically oops issue only here, not the issue with that programming. If we are not passing it by reference, because see, here we are subtracting it, right? So we need to pass it by reference so that it takes that particular k value, and then only it will give a right answer. And now if we run it, both will get accepted, and even when we submit it, then also everything would be done. So this was all for this. If you have any doubt, you could comment that down. And time complexity and space complexity I have already explained for the same. But still, if you have any doubt, you could comment that down. And yeah, this was all for today. Thank you.